All right, here we go with part B of Pre-Cal 11 Lesson 1.3, starting on page 17. All right, so this time we're going to convert entire radicals with an index of 3 or higher to mixed radicals. So not just square roots, but cube roots or anything higher. So, for example, we're going to convert the cube root of 54 to a mixed radical. So what we want to do, ideally, so there's like the ideal, most efficient way of doing it, and then there's the slower way of doing it. So I'll show you both with this one. So the ideal, most efficient is we recognize that 54 is the product of 27 times 2, and 27 is a perfect cube, and it's the biggest perfect cube that divides into 54. So we rewrite this as the cube root of 27 times 2, and then we rewrite it as the cube root. Now, you could do an intermediate step here of it's the cube root of 27 times the cube root of 2. But what's useful to write this as is to write this as it's the cube root of 3 cubed times the cube root of 2. Because then this cube root of 3 cubed becomes 3. I wish we'd actually had a different example here because there's a lot of 3's in this. Wait, I'm just going to fix this pen. I don't want it that thick. Let's make it that one. Okay. It's that this 3 and this 3 match. Okay, so the cube root, if those are the same, it just equals the number that's left over. So that equals 3 times the cube root of 2, which gives us the cube root of 54 equals 3 times the cube root of 2. So I'm just going to make a little side comment here. When you're writing that, make sure that it doesn't look like that, because that to me looks like 3 cubed times 2 times root 2. You can see that. It's not clear to me that that is 3 times the cube root of 2. So just make sure that when you're writing these things out, it's really clear what that little number belongs to. Is it the exponent on the coefficient, or is it the index of the radical? All right, the other way to do this, if you didn't recognize that 27 was a perfect cube in there, is to go, let's do the prime factorization of 54. So 54, if I divide it by 2, I get 27. That doesn't divide by 2, but I can divide it by 3, and I get 9, and I get 3 and 3. So now I've got a set of 3, so I can write 54 equals 3 cubed times 2. So then the cube root of 54, do that, I can write that too. So the cube root of 54 equals the cube root of 3 cubed times 2. Okay, so that's the process that you go through if you don't recognize the cube within it right away. Okay, and then if you're doing this for indices of greater than 3, you're then looking for, if it's the 4th root, you're looking for groups of 4 and so on. Okay, and like I said, the index and the exponent in this term here would be the same to cancel each other out. Okay, so let's convert these radicals into mixed radicals in simplest form, which means we're going to do it as far as we can. I invite you to pause the video and try these on your own, and then come back. I'm going to, I'll work through them for you to watch if you want to. All right, the cube root of 6,000. I'm having a good day, so I'm going to notice that 6,000 is 1,000 times 6. So that's the cube root of 1,000 times 6. And that equals the cube root of 10 cubed times the cube root of 6. So that equals 10 times the cube root of 6. This multiplication sign here is not necessary. Just having the number beside it does mean multiplication, but for me, with my lousy writing, it forces me to be careful about where this index goes, and that it's not mistaken for an exponent on the 10. So there's no harm in putting that multiplication sign in there. Okay, all right. This one, the fifth root of 320, again, good day. I recognize there's a 32 in there, and 32 is 2 to the power of 5. That's one you should just, I will give you a list of ones you should recognize. I'll have that for you for class next day. Yeah, because there's some that by now, like, they're just number facts you should know. All right, so this is, and you should know because it makes life easier, basically. So this is the fifth root of 32 times 10. I'm going to make sure that my sign covers all of that. So that's the fifth root of 2 to the power of 5 times the fifth root of 10, which means that it's 2 times the fifth root of 10. All right. Now we got a negative here. The negative adds an extra wrinkle. So I'm going to show you, we really want to deal with the negative first, okay? So I'm gonna do a line of things that are, you don't need to show this work, but I'm just gonna show it this time so you see clearly what's happening. Okay, so this, if I do this like the longest possible way, this is the cube root of -1 times 16, which means it's the cube root of -1 times the cube root 16, which means, well, which equals the cube root of -1 is -1, right? -1 times -1 times -1 equals -1. So that becomes -1 times the cube root of 16. So what all that essentially means is that anytime you have a negative under the radical sign and you have an odd index, you can just move the negative out and it becomes negative the cube root of the positive number that was left inside. Okay, so you can, when you understand this and you're comfortable with it, you can just go directly to here. It only works when this is odd. Okay, because of course if it's even, there is no real number solution to it, so you can't, you just say there's no answer. Okay. All right, so now we have this one. So let's simplify that. So this is 8 times 2, so this equals negative the cube root of 8 times 2, which is negative the cube root of 3 squared, or sorry, 2, sorry, I got that backwards, it's 2 cubed. Okay, sorry, 2 cubed times the cube root of 2, so that equals -2 times the cube root of 2. All right, that's the end of that. The next part of the lesson, so you could go and do questions 6 to 9, and then there is an extension video that I'll do separate. And if you're going for an A, you really need to be able to do this next set of questions. Okay, bye.